Good morning, Algebra. It's Mr. Belky back with another lesson for you today. This time we're going to be jumping into Chapter 11, and our first lesson in this chapter deals with inverse variation. So basically, inverse variation simply means that when one variable goes up, the other goes down, or vice versa. So let's take a look at example 1. The time it takes to travel a certain distance varies inversely as the rate at which you travel. The equation RT equals 250 can be used to represent a person driving 250 miles. Complete the table and draw a graph to show the relationship. All right, so we have this table here. And we have the rate in miles per hour and the time in hours that it'll take. Okay, and we're going 250 miles. So if we were going 5 miles an hour, how long would that take us? 10 miles an hour, we'll go increments of 5, 15, 20, 25, 30, 35, 40, 45, and let's do up to 50 miles an hour. I know, we're cruising now. All right, so if I plug these numbers into our equation, RT equals 250, okay? If I plug these rates in, 5 times what equals 250, okay? Divide by 5, divide by 5, so then T would equal 50. So if I was traveling at 5 miles per hour, it would take me 50 hours to get to Grandma's house. Okay, now let's continue that out. If I was going 10 miles an hour, I'd divide by 10, it'd take me 25, and so on and so forth, all the way up to if I was going 50 miles an hour, so if I take 250 divided by 50, then it would only take me 5 hours. All right, now let's take a look at another one. It says graph, example 2, graph the inverse variation in which y varies inversely as x and y equals 15 when x is 6. Okay, so y and x are an inverse variation again. Okay, so x, y equals k. We don't know what k is, but we know that when y is 15, x is 6. And so that can tell us what k is, because 6 times 15 is 90. So every time x times y, it has to equal 90. And I can set up the table. You see the table here in example 2. So when x is 2, 2 times 45 is 90, 3 times 30 is 90, 6 times 15 is 90, 9 times 10 is 90. Same thing with negatives, and so that's how we have this graph going this way, and we also have a negative graph. All right, now using inverse variation, if x1, y1, and x2, y2 are solutions of an inverse variation, then x1, y1 would equal k, and x2, y2 would also equal k. Therefore, x1, y1 would equal x2, y2. Okay? So we can set those as equal to each other, and we can solve. Okay? Which would give us x1 divided by x2 would equal y1, y2 divided by y1. All right, so what does that look like? Let's look at example 3. If y varies inversely as x and y equals 4 when x is 7, okay? So I got point 7, 4, right? Y equals 4 when x is 7, okay? So let's say this is x1 and this would be y1. Then find x when y is 14. So if y is 14, what would x be? All right, so we can plug this into our formula. Remember, x1 divided by x2 equals y2 divided by y1. All right, and let's plug in what we know. We said this was going to be 1 and this was going to be 2. So x1 is 7 x2 is x equals y2, which is 14, over y1, which is 4. Then we can simply cross multiply and divide. 4 times 7 is 28. 28 divided by 14 means that x equals 2, or x2 in this case equals 2. Okay? That's it. If you have any questions, feel free to call, email, or text, and I'll get back to you. Otherwise, you can check online tomorrow between 9 and 10 o'clock, and I can answer your questions live then. Have a fantastic day. We'll see you tomorrow.